this session will be recorded and then we can have access to that at the end of this session. And please, like I said, feel free to type your questions in the chat box, and we're going to take our time to answer the questions, before the end of the session. Now we have our guest speaker for today, Dr. Jambok. She's with the research. She's an animal scientist with USDA ARS Boonville, Arkansas. And today she'll be speaking on the strategy for reducing internal parasite in small ruminants. I'm going to turn over to Bob, and thank you so much today again for joining us. You can please take over, Dr. Bob.
Thank you, Dr. Brown. Can everyone hear me okay, or can you hear me okay? Is this
yes.
Okay? Okay. All right, good. Yeah, so I'm guessing a lot of you are sitting here listening to this or about to listen to this because you've experienced some worm problems in your sheep and goats, and it might have gotten bad because of the ideal conditions to grow worms that infect sheep and goats. And so that's what I'm going to talk to you about, strategies for reducing and controlling and minimizing internal parasites in small ruminants. And I put it in the chat box, but this is the website where you can find more information on what I'm going to be able to share with you today. What I'm going to share with you today could potentially take 4 hours or more. So you're just getting a condensed version of this. So, I mean, it can be, if you've never heard about worm control, it can be pretty overwhelming, but this little short presentation won't be too bad. But like I said, it's not going to be enough information. It's just going to be enough for you to help you decide where to go next. And I'm going to advance the slide. There we go. So just a reminder, as David said, I'm from the USDA Agricultural Research Service. It is the research branch of the USDA, and each location has a specific mission. And ours is to develop scientific principles and technologies to enhance the profitability of small-scale farms. And sheep and goats really fit well in that, especially in the eastern, southeastern states and northeastern states, but even the western range, especially when they experience rainfall, can have worm problems. So what I am going to try to cover today, well, I'll do my best and covering a little bit about biology and background of both the worm and the animal, and briefly how we got to where we are in terms of why we need to be so vigilant in controlling worms, and basically why dewormers don't work, and look at alternative approaches, which include grazing or feeding Serratia lespedeza, the use of copper oxide water particles, Duddingtonia flagrans, which is a nematode trapping fungus, otherwise known as bioworma in the US, or Livamol with bioworma. And then what I think is the most important aspect of worm control today is genetic selection. I think we're not quite there in genomic selection, but genetic selection is certainly a very important component within a flock that experiences any worm infection. And then some other considerations, and I've reminded you about the website where you can find more information. And there we go. So there's a number of worms that can infect sheep and goats. The most important one and the most pathogenic one that I'm going to focus on today is Homuncus contortus, also known as barber pole worm. It infects sheep, goats, deer, and exotic ruminants, including those in zoos. It's a blood-sucking worm, so it's highly pathogenic. It causes anemia, so you can kind of get a sense doing a FOMACHA score how anemic an animal is, how pale they are, essentially how much red blood cells have been lost due to the feeding activity of the worm. And it also causes bottle jaw, so this protein leakage that we can see with some edema that tends to pool under the jaw. This can look similar to other conditions, and I see on Facebook that people get confused about this with a couple other conditions. So if you couple this with a FOMAC score, you can clearly see that the bottle jaw is likely associated with worms. So it is the most important worm parasites in um, any warm, humid climate in the southeast and other parts of the United States and the world. Other parasites include Trichostrongylus, which we might see in cooler weather, causes diarrhea. And then there's a protozoan parasite, Coccidia, which can also cause diarrhea. And there's a lot of that can be seen right now, mostly affects lambs and around the time of weaning or even before that, or when the animal is stressed. And I'm not really going to talk about control methods for that, except maybe one. But in the southeastern U.S., one of our biggest problems is that the worms are resistant to available dewormers. And so guess what? We need to be able to rely on other things besides dewormers. And if we do have dewormers that work, we need to make sure we maintain their efficacy. So this slide gives us an overview of the life cycle of the worm. So I'm going to start here where we've got the animal grazing what are called infective larvae, L3 larvae. And so these larvae have a pretty protective sheath around them, protects them from environmental extremes, drought, being washed away by rain. They do run out of energy after a while when it's really dry and arid. But if there's any moisture in the soil, they're protected for quite a lengthy period of time. And that's why they're kind of always there as long as we see dew on the grass, the worms are likely there too. So that's kind of a good worm test. So the animal picks these up along with the grass or forage that they're grazing, and these worms, barber pole worm will mature in the abomasum or the true stomach. There's some other intestinal worms, but barber pole worm focuses on the abomasum, and then it reproduces, and the eggs that are produced wind up in the feces on pasture. So so this animal here, you can sort of see some larvae or some adult worms in here and blood. So it does cause a lot of blood loss. So when we see the eggs in the feces, we can do what's called a fecal egg count and identify. We can't identify which strongyles are which. So we can't identify Trichostrongylus from Homunculus contortus, but we know there's an egg count, and if there's anemia coupled with it, then it's a pretty good chance that this is barber pole worm, but we can't say for sure just from an egg count. So these eggs are deposited on the pasture, and then after a couple days, especially this time of year, it doesn't take long before these eggs hatch and then mature to the mature stage larva again. This whole time frame here from start to finish is about 5 weeks. It only takes about 3 weeks from the time an animal picks up some larvae until they're start to 3 to 4 weeks till they start to produce eggs. So it's a pretty fast life cycle, and that's why there can be several generations of worms in one summer season. So barber pole worm is a huge problem because it evolved in the tropics. It thrives in warm, wet climates. It's a very prolific egg layer. So it can lay 5,000 eggs per day. So for example, if you have 30 goats or sheep, laying 300 worms per animal, that's 1.5 million eggs per day per animal, and leading to over 1 billion eggs per month. Now, they're not all going to survive, but even half of those that survive obviously are going to cause a huge issue. And that's why you can suddenly come up with worm problems within a flock, especially if they're really susceptible or stressed. So barber pole worm has a long transmission season. We in Arkansas can essentially find some year round. They do, so we tend to see more Trichostrongylus by late winter, or yeah, somewhere around December, January, February, we'll see more trick strongyls, but the rest of the year we'll see a lot of homuncus or barber pole worm. Short life cycle and immunity to worms is slow to develop, especially in a lot of wool breeds and goats. It can take up to 6 to 8 months of age. And around the time of lambing and early lactation, the immune system is suppressed in the dam, and that's the time where the mom is putting out the eggs and the larvae for the next generation of her offspring, and that's bad news. That's what continues the life cycle of the worms. So just kind of illustrate the point of how we got to the point of mostly resistant worms. So if we're using a dewormer and let's say we have right, let's say we have mostly susceptible worms, but there's 2 resistant worms. When we go to deworm all of these, only the resistant ones survive. So the next generation is all resistant. And for example, the old recommendations were to put animals onto a clean pasture after deworming. Now the only good things surviving in that clean pasture are resistant worms. So we don't recommend that anymore. We recommend to, if the whole flock or all the lambs or kids need to be dewormed, don't put them on clean pasture. Put them back on that dirty pasture at least for a few days. Just so that they can start to pick up some of those susceptible worms that are still on pasture, on the dirty pasture. It's a huge concept. It's called refugia. And I could spend several slides on this. So there's, like I said, there's more information on this on the website. But so the goal is to use selective deworming. So hopefully we don't have to deworm the whole flock. We're not in that much trouble yet that we've got to deworm everybody. And we can use selective deworming. In using selective deworming, we are maintaining refugia. So those are the worms that will respond to the dewormer. So the susceptible worms. We want to maintain as many of those as we can, either on the pasture or in the animal. So in the animal, which would be the ones that we're not deworming, and then on your dirty pasture, if we do have to deworm all. So the more of the population that's in refugia, the slower the rate in which resistance of the dewormer will develop. And then, so selectively deworming will significantly increase the percent of population in refugia. So that's a pretty big concept. If the worms are already completely resistant to the dewormer, none of this is really going to matter at all. So we're making an assumption that we've got some worms that will respond either to the dewormer or some of the alternatives that I'll present in a few minutes. So one way to achieve selective deworming is the use of FOMACHA. So I'm not, I mean, again, there's a whole nother presentation just on FOMACHA alone, but basically is where you look at that lower membrane, to push, pop, pull action. And then you can also look at the condition of the animal, whether it's got bottle jaw or if it just looks very poor and lethargic. Those are the animals that do need to be dewormed. Deworming based on fecal leg count isn't a very good idea because each animal has its own threshold. It's useful in determining genetic resistance to the worms. So doing a whole contemporary group fecal egg, so each individual in a contemporary group has their fecal egg count collected. Those with very low egg counts, especially repeatedly, would be considered resistant compared to if there's some with very high egg counts. And those are the ones that should be removed from the flock or herd. So when we think about going forward, when we think about controlling parasites, we want to use a system of parasite control. So years ago, when dewormers first came on the market, that was a silver bullet. That's what everybody used. And they ignored everything else. They wanted optimal production, so they dewormed everybody. And they dewormed everybody, and that's a lot of dewormers dewormer resistance developed very quickly, like monopental, which isn't here in the US, but it's available in other countries such as New Zealand. Once introduced, resistance developed very quickly, even within a summer. So some of what we look at in terms of system of parasite control. So we're targeting the gastrointestinal parasite. In using this system, we want to go from having dead or sick animals to having all healthy animals. So we look at the climate and environment. So right now it's very warm and moist, humid, and so it's ideal for worms. So we have to be on high alert. Make sure the nutrition program is optimal. So that can be assessed through body condition scoring. So animals in good body condition score are going to be more resilient to parasites compared to those that are very thin. I see there's a question about Sericea lespedeza, and I'll talk about that in just a second when I get to that slide. But lespedeza, or part of our grazing program, even using rotational grazing or biowarma, those are all targeting pasture and nutrition. We want to minimize stress, considering the biology of the animal, whether they're around the time of weaning or in lactation. Those animals are going to be more susceptible than those in a maintenance phase. And then I put this big red circle around genetics because I think it's really important to have resistant animals that, I mean, I'll show you an example of how we, from a research standpoint, how we got to be too resistant, which is a good problem to have for farmers. And then when all of these fail, that's when we need to turn to either chemical control or copper oxide wire particle. And we can also use both, which I'll show. So, okay, Sericea lespedeza. I'll remind me to answer that question, David, about whether it's a noxious weed and invasive. Remind me to answer that if I don't. Okay. So, so in Arkansas, Missouri, and a lot of other states, you can find Sericea lespedeza along the roadside. It was introduced by NRCS years ago as a conservation tool to prevent soil erosion. It was, again, one of those short-sighted things because yes, it is very invasive. The good thing is, and you can see in this picture here, goats like Sericea lespedeza. They like it. At least in Arkansas, they like it until about the middle of July, and then they tend to kind of not really like it after that. I think it just becomes too mature. So what's the big deal about lespedeza? Why is this a good plant to graze? Here's a picture of some AU grazer lespedeza that our sheep are on, and this is a mixed pasture of grass and lespedeza. But why is it such a big deal? We've done studies early on, close to 20 years ago or so, where some research was done at Langston University years ago, and they accidentally saw that goats that were grazing lespedeza had reduced fecal egg counts. So we wanted to figure out what was going on, if we could repeat that intentionally. So this is a study done at LSU where, so on this axis here, we've got fecal egg counts, and obviously the higher the egg count, the worse it is. And then this experiment ran for 63 days. So animals were artificially infected with worms to simulate a pasture infection, a natural pasture infection. And then they were on either a Bermuda grass hay or a Sericea lespedeza hay, where you see that green bar. And the Sericea lespedeza hay kept fecal egg counts low. Now it wasn't zero, and the worms didn't die, but it did keep the fecal egg counts lower, and it did help alleviate anemia. Whereas the controls, their fecal egg counts went very high. But so after feeding stopped, the fecal egg count did go up. As I said, the worms didn't die. So that's one of the drawbacks of Sericea lespedeza. You have to be very careful here. And this is a good time to keep eye on your goat or sheep, or potentially give some copper oxide wire particles to get rid of any remaining worms that might still be there. What I really like about Sericea lespedeza, and I said I was going to show one slide about coccidia control, is that it does a really good job both treating and controlling coccidia. and you really have to push the amount of Lespedeza the animal is eating to get a good effect. So this experiment here was another study done at Louisiana State University. So weaning was done here. Animals were given, I believe they were given an artificial coccidia infection. And so in control animals on the Bermuda grass, they're oocyst. So it's kind of like a fecal egg count, but these are oocysts. It went up, indicating that these animals were had coccidiosis. But the ones on Lespedeza, they stayed low, and even after the feeding stopped, it still stayed low. So that's the thing I like about using it for coccidia control, is it maintains its effect, because with coccidia, once an immune response in the animal is triggered, it'll keep working. So how effective is Sericea lespedeza? Hey, I see a question about that. It's a good question. And so the most studied variety is AU grazer. We don't have a lot of other data on other species. So we have done some research years ago here in Boonville on using what I think was an interstate variety or some common variety of Sericea lespedeza, and it didn't really do very much to reduce fecal egg count. And about 2 months ago, we did another Sericea pellet study that really didn't really reduce fecal egg count. The egg counts weren't that high, and it probably had some reduction on oocyst count, but we probably didn't have intake high enough. So effectiveness is the more you can get into them, the better, at least for a short time, for 2-3 weeks. And I mean, it can be as high as 14% protein, so it can meet their nutritional needs. Over a long period of time, it tends to tie up some minerals. So make sure you've got a really good trace mineral program. Somebody has a comment that Sericea lespedeza pellets are so big. I'm not aware of pellets being that big. I mean, these are pretty small pellets that we're feeding that you get from the Sims brothers. I'm not sure. I don't know where those pellets are coming from. And then, so as I said, over time, we do tend to, so after about 28 days, we kind of get a really nice effect. But then, and then body weight. So the green triangles here are those are lambs that grazed just Lespedeza pastures. You saw that a couple slides ago. And they did start losing weight. So either they didn't like it and they weren't eating enough, or it was kind of binding up some minerals that were kind of impacting their growth a little bit. So I do like it in the short term. Over a long period, you just got to watch out. So copper oxide wire particles, you might see it abbreviated as COWP. Copper oxide wire particles, it's really one of my favorite control methods for barber pole worm. So by itself, it only targets barber pole worm. It doesn't target the others. And I'll talk about how we can use it to target others. So what is it? It's these little particles that were developed to alleviate copper deficiency. So even in sheep, we can see copper deficiency, and here in Arkansas, we can see a lot of that if we don't put a little bit of copper in our mineral. Now, if you're feeding a lot of copper, or especially sheep are exposed to a lot of copper, then you might not want to use this, because it will increase the level of copper in the animal. So what happens? So the copper's given to the animal as a bolus, or even in a marshmallow or a little cookie. It's given to the animal, and it makes its way to the abomasum. And remember, that's where the barber pole worm is. And we're not really sure what happens, but it results in expulsion or death of the adult nematode. We think it's more than just increasing copper. We think it's having maybe a physical effect or some effect in the abomasum to make the worms simply go away. And they don't come back. So they're either leaving or dying. Again, we've got really nice fact sheets on how you can use these on your farm. So where you can buy them, whether you want to buy them in bulk or whether you want to buy small amount. And I can't remember if I put on the next couple slides, so pardon me if I repeat this. So we don't recommend using more than between a 0.5 gram and 1 gram to any animal less than a year of age. and that's not very much at all. It's a really low dose, and that's what makes it relatively safe and make sure we don't give copper toxicity. And for adult animals, somewhere between 1 and 2 grams. And we really don't have to go higher than that. So you'll find boluses on the market that are 4 grams. They're fine to use if you use them only once in a summer. But if you're going to use them more than once, you might get yourself into trouble. And copper toxicity is no joke. Animals will die from copper toxicity. And it's a really fine line between what's not enough and what's too much. So it's important to keep in mind. This is one of our earlier studies just to show you how quickly copper oxide works. So we had given an artificial infection to the lambs of Homunculus contortus. And you can see that, so this is fecal egg counts again and day of study here. You can see here how the time frame when the animals begin to shed eggs from the artificial infection. So this is 1 dose of worms that we had given them. So their eggs, fecal egg count kind of maxes out after about 28 days. These animals were not dewormed, and these all got a dose of copper oxide. So this was a pretty high dose. This is before we did the dose titration of going as low as we can go. But so we don't have to go this high at all. And I don't know if I'll show you, but I'll show you that it does increase in the liver, and that's what we have to be careful about. But you can look how quickly fecal egg counts do come down, and the level of anemia, it gets better as well. This study here is one where we weaned lambs on day 0. So again, we've got the fecal egg counts on the y-axis. I think I said X earlier, on the y-axis, and day of experiment here. So what we want to know, if we give levamisole versus a half or 1 gram to weaned lambs, and remember, these guys are on pasture, naturally infected, so they're gonna be stressed. So can we use these 4 treatments over a summer period and get them to potential market weight? And they weren't quite there, but close enough. So sure enough, we gave them treatment at weaning, and fecal egg counts came down, and then they naturally came up because there were lots of worms on pasture, like we see that this occurred about this time of year years ago. So we gave another treatment here. So I think we gave treatments every 6 weeks. So that was the design of this study. And then they came down, and I believe these were dorbercatodin. You can see now that the animal's immune system is starting to mature, and so they can really kind of control their own worms at this point. So we didn't need to give these other 2, but from an experimental standpoint, we wanted to see what was going to happen in the liver to the level of copper. So and you can see even with levamisole, it doesn't it wasn't 100% effective. So we even had some resistance in the levamisole as well. So it didn't come all the way down to 0, and that's the problem that we have. So and you might even notice down here when the 4th treatment, the animals that got the copper oxide wire particles, it didn't reduce the fecal egg count because at this point there were other worms instead of the barber pole worm, and so it wasn't going to control those anyway. And so this shows what happens to the liver. So those animals were processed and took the liver and looked at the concentration in the liver, and that's the best measurement to measure copper. So this was the levamisole group, and they were actually copper deficient here. This is where we want to be. So in our part of Arkansas, giving that half or 1 gram treatment actually put them about the right place in terms of where we want to be. So we're in a copper deficient area. You have to be more careful, like I said, if you're in an environment where you've got lots of copper. So it does increase it in the 1 gram. I can't remember if this was a statistical difference, but this is a difference. The lambs that got the 1 gram, their level copper did increase more. So I did mention that you could potentially use copper oxide with something else to get the other worms. So in the study, if we focus on this lower slide here, kind of ignore this one for this slide. If we focus on this lower slide here, again, we're looking at fecal egg counts. And so we have either control animals that did not get any treatment at all. This was a quick study over a 14-day period. Or we've got animals getting only albendazole, which is a valbazen. So that are the white hatch bars. Those getting only copper oxide, which is just the dark blue bars. or animals getting both. And you can see this was a mixed population. I can't remember what the population was, but we had both barber pole worm as well as Trichis strongylus. And so, and we knew that valbazen barely worked at all. I mean, we did get some efficacy, but here's just the albendazole, so not very much. And then even the copper oxide wasn't completely reducing the fecal egg count. But now if we combine both treatments, the copper oxide and the albendazole, we get down to almost zero. And this was the first time that we ever saw that we could address treating those dewormer resistant worms. And so that was pretty exciting. So we could use a dose of the copper oxide and the valbazen. And nowadays, when on farm here, when we have to treat an animal, we'll use 2 different dewormers plus a copper oxide, and we usually get down to zero in most cases. Okay, so I see a question, and I might not be seeing all the questions. We can get to the ones I missed, but I see a question: how quickly does the level in the liver come down after giving a bolus? It's probably going to take a little while. So when we give the copper oxide wire particles, it's going to stick around there in the abomasum. So those particles are made to stick in the abomasum. So it's going to take, depending on the dose that you give, it's going to, if you give a big dose, it's going to take a long time, 6 months to a year before you start seeing normal levels in the liver again. So that's why with sheep, it's a pretty big deal if you give too much. It doesn't come down fast. Okay. I see Linda's on there. She can answer some of my questions too. Thanks, Linda.
Yeah, I was just sending a message for helping to jump on those questions.
Excellent. Thanks so much. Yeah, and Linda was one of the she was one of the ones that wrote some of the fact sheets on copper oxide. So she's a great resource to have on board here. And you'll see in some of those publications, I don't know if it'll be these exact pictures, but this is what our little half-gram bolus looks like. And depending on like the size of the capsule you use, it'll look different. So this is a bigger capsule than this. But anyway, this is the original. This is the Copashore, which also comes in a form for sheep and goats. But I think this is a 4-gram bolus. And like I said, I think that's too much. If you need to use it more than one time, it's too much. I had a producer ask, okay, I don't have a scales. How do I know? How do I easily know how much is 2 grams, for example? And so this is just eyeballing it using a 1/4 teaspoon gives you about 2 grams. So giving you, if you got an 1/8 teaspoon, that'll give you about 1 gram. So that's just eyeballing it. Okay, so I'm going to switch gears and talk about how you can target worms on pasture. So Bioworma, or Duddingtonia flagrans, is a nematode trapping fungus. So of all the control methods that we've talked about so far, including dewormers and copper oxide, we're targeting the worms in the animal. Now we're targeting worms on pasture, and it's not magic, because it's something that's using bioworm is something that takes patience, time, and understanding. So what happens is these fungal spores of this fungus are fed to an animal. So the spores are pretty tough. They're meant to withstand harsh environmental conditions, and they can make it through the gut of the animal and pass through in the feces and still intact. And then what happens in the moist, wet feces alongside the nematodes that are the eggs that hatch in the nematodes. So the nematode or worm larvae develop at the same time as the worm trapping fungus. And guess what? They paralyze and consume it. And that part of it is magic. So it's estimated that about 10% of the worms are in the animal and 90% on pasture. Bioworm is effective against multiple worm species and resistant worms. May not be as effective against strongyloides, and I'm not going to really talk about that. There is a fact sheet on strongyloides, which is kind of it's a nasty worm for a little while. But anyway, you can look that one up if you've got any unexplained diarrhea somewhere around May. At least in Arkansas, it happens in May. Okay, so you can get biowarma or Livermol with biowarma through Premier One. You can also get it through feed mills and veterinarians, but most producers are finding it through Premier One. At this point, that's basically where you can find it. So this fungus, it's a naturally occurring fungus, and researchers found it years ago in the 80s and 90s, and then once they came to understand what it was and what it did, they conducted a number of research studies. But one of the things that they did is it's not detrimental to soil nematodes. You can't just spread it out on pasture because it doesn't move around, so it's confined to the fecal pellet when feeding, and that's really where you want it. So this is what it looks like. Here's the spore. It's a mature chlamydospore. It's got nice thick walls, goes through the animal. And then after a few days of when the egg hatches, you've got the nematode. So here's the, I don't know what it is, Homunculus contortus or your gastrointestinal nematode. And these are little fungal traps and loops that form around it. And then over time, the fungus actually kills it and eats it. And then over time, it's gone. And that's pretty fascinating. These slides or pictures are from International Animal Health Products, who produce the biowarma. So this is a cartoon that I made just so that you can understand. It doesn't do anything in the animal. I get so many questions from producers. Well, I've given this for 8 weeks. I don't see any difference in the animal. You won't see any difference in the animal. So the spores are fed to the animal, and they happen to go into the abomasum, and that's where the adult worms are. Adult worms are laying eggs, and then they happen to pass through the gut. They're going to go through here whether the worms are there or not. That's a fact. So this is just kind of a blow up showing you the eggs, and the adult worms producing the eggs, and the spores are right there with the eggs, and these guys are what come out in the poop. And then the poop is on pasture, and what you have, this is supposed to be larvae and fungus developing, and then you see this. So doesn't do anything in animals. So what we're trying to do, if we start with a clean pasture, so let's say we rest a pasture for a couple months before we know the worm season is going to be bad, and then we start giving. Ideally, what you're going to want to do when starting is deworm everybody with something like copper oxide and an effective dewormer or two, and then start feeding the bioworm and put them out on the clean pasture. And any resistant worms that will make it through over time are going to be taken care of by the fungus. So that's ideally how it works. It is an expensive product. So it is not something you really need to have a plan if deciding to use biowarma. And so I have the task of updating the biowarma fact sheet on the consortium website, and I will do that soon. It's up to date except for one thing that I'm going to show you next, maybe. No, well, not next. So how do we know in research whether it's working or not? So instead of fecal egg counts, now we want to look at doing a culture and looking at the infective larva. How many infective larvae? So remember, if the fungus is there killing the larva, well, let's start with the control. Here's a control animal not receiving the biowarma, and so you get lots of infective larvae that come out in the culture, so after about 7 days. And so what you're going to see is in this scenario, you see lots of larvae on grass. In the scenario where the animals are getting Dunningtonia here, we don't see as many larvae. And so that's essentially what you see on pasture. You won't see as many larvae. So that's just kind of, so this is an actual research study, but I just put a little diagram to help you understand that's the benefit of it. And so there's a lot of farmers that, I hope I'm doing okay on time. I think I'm okay. There's a lot of farmers that don't want to feed a supplement. And so they've asked me, can I what can I do? Is there any way to give it? And so we did a study both in Boonville, pretty controlled study in Boonville last year, and then there was a study done at LSU. So we had a control group that didn't get anything, and then we had a control getting biowarma as recommended in the feed supplement, which is represented by the green triangles. And then we had a group that we put an aged biowarma mineral, and then fed them the mineral. So we aged it to simulate what might happen when producers put it out. So it was aged for 7 days. So this is a day 0. Again, these are the larvae recovering from the feces. So normal, and you get a lot of variability in fecal cultures. There's a lot of things that can go right and wrong in fecal cultures, and that kind of shows here. But this is the larval recovery in the mineral, and it does go down. And in this controlled study, it was reduced even better than on the feed. But when we did the field study at LSU, it was comparable. So, and it still went down. So in the field study, animals. So in the control study, we gave a known amount of mineral to the animal each day, but in the field study, animals could go and lick their own mineral in picking up the spores there. So it was effective. And so we haven't done a whole lot of research with the mineral beyond that, but we think as long as it's reasonable and you keep the mineral out of the rain, and I don't know if it's going to survive past 6 months, but it is an option. Genetics, this is, like I said, my most favorite parasite control method. So what is genetic resistance? Is an animal's ability to resist parasites is heritable, and that's a good thing. Heritable traits are something that will be passed on to offspring. So back in 2004, we could actually see that we had 2 rams. There was an orange, called them Ram B, and a green Ram A. And in this wet year of 2004, the offspring, so these are the offspring, there were at least 20 lambs per sire represented in each of these bars. So the more susceptible Ram B had higher fecal egg counts than the more resistant Ram A. 2005, it wasn't a big deal because there wasn't that much rain, so we didn't have that many parasites. And that did transfer over to level of anemia as well. I don't know how many people are on the National Sheep Improvement Program, but it essentially equated to the green ram having a post-weaning fecal egg count of -3, and the orange more susceptible +119. If you're in an NSIP, you know what that means. If you're not, then I'll have to give you another webinar just on that alone. But anyway, level of anemia. So this time more is better. So essentially more red blood cells. And so that more susceptible ram, his offspring were more anemic. And then we did a more comprehensive study a couple of years after that and showed death loss. I paired it with estimated breeding values again, but essentially keep in mind, if you don't know NSIP, keep in mind that the more susceptible rams, in this case, we had a 30% death loss from one particular sire and a 0% death loss on quite a resistant sire. So that's a pretty big deal too. And that's really the bottom line when you get to conditions like we've had this year where it's pretty wet and there's lots of worms out there. We want to make sure we're using rams or bucks. Goat industry isn't quite as far as the sheep industry is in terms of genetic selection for parasites. And it's possible to get there. We just need a more organized way to do it. Okay, so as I mentioned earlier, I had in our flock, we actually went too far with resistance. So again, these are estimated breeding values. So lower is better. This means animals are going to be more resistant. So just keep in mind that this is more susceptible, more resistant, and this is over time. We started using estimated breeding values in 2011. This was the average of the Katahdin flocks that were in NSIP. And then using that selection, we were able to reduce the amount of susceptible animals. And we got to a point around 2020, 2021, where it was so low that we could no longer do parasitology studies. So I had to add back a susceptible sire, which is why that goes up here. And sure enough, by just adding a susceptible sire or two, that really wreaked havoc on the pastures. Just having a few more susceptible animals put a whole lot of worms out for the rest of the animals and challenged everybody. So that's a good thing. So a couple other tidbits before I wrap up. Nutrition is extremely important in managing worms. And the most important measure of whether your animals are getting enough nutrition, whether they're just on pasture alone or getting pasture and supplement, the most important measure is looking at body condition score. There's some good, I know Langston's got a good body condition score tutorial on their website for sheep. I think even if you just do a search for body condition scoring in sheep, you'll find something if you're not sure how to do it. If you don't know how to do it, it's one of the most important things as a herds person to know. So increased protein during times of stress can increase the resilience to worms. It can be provided as a supplement or a higher protein forage. And if you're not sure, you should do forage testing. And then we've got some fact sheets kind of looking at some of these concepts there. This just shows you how animals can be more resilient to worms. So this is the same population, but the blue was on a lower, so this is a 1 pound of a supplement with some low quality hay versus a 1.5 pounds. So those animals on the 1.5 pounds were less anemic, so their pack cell volume was higher compared to that. And that was a pretty big deal. And that can be the difference between life and death. And so that's how important nutrition is. I think I briefly mentioned periproteinuric rise. The immune suppression around the time of kidding or lambing can lead to increased fecal egg count or parasite infection. So that's a time to be really cognizant of the nutrition program of ewes and does. And this slide here is in Katahdins, shows the peak fecal egg count occurs about 30 days post lambing. And again, we've got some more information on that on our website. I'm gonna skip this slide. There is an effective season, and it's more complicated than what this slide shows. I'm gonna skip that for another webinar perhaps. Things that don't work, things that we've even done research on that do not work. Herbal dewormers, we didn't, and we followed the directions exactly and it didn't work. Garlic, maybe we didn't feed it every day, but we gave it its strategic time points and it didn't work. Papaya seeds, and again, maybe it's the delivery method, but we didn't see any effect. Diatomaceous earth, we did a short study here, and we didn't see any significant effect. A lot of people think the DE works, and there's actually some publications that not really good convincing publications, because a lot of times when researchers do studies and find that it doesn't work, they don't like to report it, but it doesn't work. A lot of people think it does. That's why I kind of and it can be dangerous to inhale because there's some sharp microscopic particles that can affect your lung health. Ginger, we didn't see any good effect using ginger. There's a fact sheet on herbal dewormers that you can look at. And one thing I forgot to mention earlier on the copper oxide, copper sulfate is not the same as copper oxide. So copper sulfate it's a salt. It dissolves more quickly. And so it can increase copper in the liver a lot quicker too. But we even did a study with copper sulfate and showed that it didn't reduce fecal egg counts. So we don't recommend feeding copper sulfate unless you're working with a nutritionist and you need to get copper levels up. Don't use copper sulfate by yourself. Make sure if you need it, work with a nutritionist. Some other considerations, look at your animals, pay attention to those lagging behind or those that look different. If the head's hung down, lying down, not getting up, or has bottle jaw, those are the ones that are going to need attention and hopefully a dewormer that works. Select the best and cull the rest. And I know that if you have an animal that has a name, probably just put it on concrete and don't worry about putting it on pasture. So you don't have to worry about culling it. And I get it. I've had animals that become pets. So I get that. quarantine new animals, assume they have resistant worms, and use 3 dewormers from each class. If you're not sure what I mean about that, there's a fact sheet on combination dewormers that Ray Kaplan wrote, and I believe was updated recently. And any other information that you didn't get or want more information, like I said, visit the website. And that's what I got.
Oh,
I know
thank you.
I know I left out. I see a couple
Yeah, I
questions.
posted some questions on your chat box. You jump on that, please.
Okay, I'm not sure where to start because they go up kind of high. So
Yeah, that was when you were talking about the copper oxide.
okay, so um, I don't know. I see a question on, and if I miss something, somebody let me know. I see a question on tree bark. Does that work as a natural dewormer? Nobody's, to my knowledge, nobody's done anything except for the pine bark out of Tuskegee University. Dr. Min did that and did show some effect of reducing fecal egg counts, not to the same extent as Sericea lespedeza, but so, and sometimes goats naturally like to eat that tree bark, and there may be some natural um, magnetism to the tree for that reason. Um, um, that specific tree bark was pine bark.
Yep.
There's I see something on oak and chestnut trees. We just finished a study, and I know we didn't get enough. I get a lot of questions about walnut hulls, which are pretty popular in this part of the country. We did feed some walnut hull powder. We didn't really see a difference, but I really don't think we gave enough. So the reason we didn't give enough is I couldn't show our animal care and use committee that it was going to be safe to use more than that. So there's a toxin in walnut hull powder, juglones. I don't know if I'm pronouncing that right, and it can cause some severe problems in animals. So we didn't feed very much. It was about a gram a day, and I had a feeling it wasn't going to do much because it wasn't enough. But we didn't want to make the animal sick, so I can't really. I know there's an interest in that, but it's hard. Sometimes on these alternatives, it's hard to know what a safe dose is versus what's going to be enough to kill the parasite. So, um,
Dr. Buck, you want to speak to the multi-species grazing and how that helps with controlling internal parasites?
yeah, so the question is on how effective is multi-species grazing. Um, the literature is pretty mixed on it, and I don't know if it depends on the species. So let me first say sheep and goats are not considered multi-species grazing because they both have the same parasites. So when we talk
Yeah.
about multi-species grazing, it would be combining goats and cattle or sheep and horses, maybe even using poultry, though um, that hasn't really been researched very much. And so some studies show goats really benefit from multi-species grazing with cattle, but cattle don't benefit that much. And there hasn't been a lot of benefit to sheep in multi-species grazing. Um, so the premise is that cattle and sheep or goats don't share the same parasites. They do overlap slightly, but not, they don't have the same pathogenicity. Um, I mean, it's not going to hurt, and you're certainly going to get more efficient use of the forage. So that's the good thing. And maybe there's some benefit, but it's pretty hard to pick up in research trials.
Yeah, there's a question on the biomer, and I don't know if you can see that from Tammy.
Um, I'm not seeing the question on bioworm. I may not be down far enough.
Okay, can I read that for you? I heard there was some research on giving biowarmer less frequently than currently recommended, like other day. Do you by chance know if this is being researched? She wanted to know if you can give biowarmer, less frequently as opposed to giving, every day to the animals.
So I had a Sarah grant that was supposed to look at that, and we ran into some problems early on in the study. We weren't able to address it. That was one of the things we wanted to address. So we wanted to look at more economical ways to administer biowarma. So giving biowarma every other day, obviously if it works, you're saving 50% of the cost. So it probably works to an extent, but you are going to have more. You're going to have more larvae that escape the fungus. And the thing is, if you have loads and loads of larvae, it's probably going to be beneficial to go with a higher dose of fungus. But if you got a low level of larva, let's say, for example, and this is not based on research data. This is just based on what's in my head. So if you've got something like 500 eggs per gram, for example, you might be able to get away with giving it every other day. But if you got pretty high levels, I don't think you're going to be able to get away with giving it every other day. But then on the other hand, you're also, there's probably a lot of other things that you need to be doing in addition to biowarma to get control. If you've got fecal egg counts that reach 10,000 eggs per gram, there's probably a lot of other things to look at first before biowarma. So I mean, I by all means want to support the use of biowarma. It took the company a lot of resources to get it here in the US, and we're grateful for that. But as producers, you have to think about the bottom line, how much you are making and spending per animal. So yeah, it's a balance, and it's going to take a lot of thought if you're going to use biowarma. You just have to make sure you're using as many different control strategies as possible. I know I didn't completely answer that, but hopefully kind of get it around it.
Thank you, Dr. So there's a producer here. She wants to know if she can mix biowarmer with Durafem minerals. That without leads to very good efficacy. That's Megan Clark.
I'm not seeing the question. So can you mix biowarma with a trace mineral?
With Durafem minerals. She said Durafem.
Oh, I see it.
Yeah.
Yeah, probably. So here's why I say probably. So you can mix it with a biowarma, with a mineral. So when you are weighing out that biowarma, it's a pretty small amount, and you have to, so this is one of the problems right now. You have to use a respirator if you're going to be mixing small amounts of biowarma, because and that's why Livamol was made for farmers, so they don't have to mess with breathing the fungus. With the biowarma, it's much more concentrated, and if you breathe that and get the fungus in your lungs, we don't know what's going to happen. And you can't just wear a mask; it's got to be a respirator. And so we're hoping that some feed companies will mix it for producers. That's what we're hoping the next step is going to be, so that you can actually purchase it. If you do have the ability to get a respirator, it is going to be a pretty good way to provide the biowarma. Just and it states that right on the package, the biowarma package, that you need to use a respirator. So read your package.
Great, thank you so much. I think that's all for today. Thank you so much, Dr. Bob, for your expertise and taking time to speak to our audience today. Thank you, Linda Coffey, for always being available to help us out today. And we're going to see you again in August, because we haven't fixed day in July. So we're going to see you again in August with another topic. Thank you, Dr. Walker, once again, and everyone enjoy the rest of your day. Bye.
You're welcome. Thanks for having me.